Hey folks, welcome to 2025. I'm Sony, also known as the Canadian Data Guy. Starting now, all of our blogs are going to have an accompanying video, and I'm committed to publishing a video every other week. Let's explore our latest blog, which is about how to generate a terabyte of synthetic data in less than $1. We are going to generate IoT data, but you can create any data set you like. I'm going to leverage a 4-core machine, and each row is going to be about a kilobyte of data. The speed which we are aiming for is 1 million rows a second. You can go higher. So with 4 cores, I'm hoping for a million rows a second. You make it 8 cores, you'll probably get 2 million. You go to 16 cores, you'll probably get 4 million. Actually, write 16 cores, it's able to produce 4 million rows a second. Now let's break this down. 2 billion rows roughly constitutes 2000 gigabytes or a terabyte. If you produce 1 million rows a second, it would take approximately 1000 seconds, which is 16 minutes. So within 16 minutes with 4 cores, you'll be done with a billion rows. These are some screenshots about when I did it. I was able to get a million records a second, but I'll show you the demo. So first things first, why do we even create synthetic data sets? So a couple of reasons. First, as you can think of, is privacy and compliance. Dev workspace can't have broad data, right? That's one of the reasons, which is if you are in healthcare, you are in finance, a lot of times you don't have the ability to have the data set which you would like in a dev environment. So again, one of the reasons where you should create a synthetic data set. Other reason, which is my reason, which is why I'm doing it, is I actually needed to test the boundaries of an application. So I needed to create like a multi-terabyte data set so that I could check the performance and benchmark the application. The third thing, and which is quite useful if you try it, which is development acceleration. A lot of times you're dependent on upstream teams to give you your data set, but either they're running slow or they don't have time, or even if they give you the data set, they give you a very small data set. So you can't actually test on that scale. So if you create a synthetic data set, essentially you decouple yourself, which is you can develop your whole pipeline without actually seeing the data set. Whenever the upstream team provides you the dataset, you can quickly check your pipeline against their dataset. So basically, don't wait on them. Produce your synthetic dataset, develop your ETL pipeline, develop your CI/CD process, and once all of that is working, then once the actual data arrives, you can quickly finish your project. Those are the reasons you'll create a synthetic dataset. As I said before, the hardware I used was a 4-core machine with 32 gigs of RAM. I use Photon in my example. Now let's get into the code. The blog has the code, but I'll show you the code in practice. This is my notebook. The first thing we're going to install is a library called DLB Data Gen. I'll get into that. Let me first run my code. We are installing a library to generate the datasets, a couple of imports, the number of partitions. I have 4 cores, so I ask Spark to generate data in 4 partitions. You can change this number. I'm generating a million rows a second. You can go higher. Based on what I found, a million and 4 cores is a good combination. If you're trying to do 2 million, I would say get 8 cores. After that, you will see that I'm specifying a schema. I'm generating IoT data, so I'm specifying the schema. I'm using this particular library, which is helping me generate the data set. I'm just creating a streaming data frame. Streaming data frame is just a data frame. The streaming means it's being generated continuously. I'll quickly show you this display command. So display command you can use to actually see the data set. So this way you can see what data you're generating before you write it. You can do a display of any data frame, whether it be streaming or batch ETL. I'm generating a device ID with some timestamp, with some readings, and then in the end, I added an extra data payload column. This is a random column which I added. I needed to actually construct a kilobyte worth of row. So the last column is about 800 bytes. So this will help me get my 1 kilobyte row, which was my aim. And so we have a streaming data frame right now. It's called streaming DF, and we need to write it to a table. So one thing which people don't know is I see people miss very often is they don't give their streaming queries a name. Spark Streaming has this parameter called query name. You can give your streaming queries a name, and once it shows up on Spark UI, you will see the name of the query along with the streaming ID of the query. In this one, we are doing a write stream. We are saying call this stream IoT data stream. You can call it anything else. Output mode is append, which meaning we are going to append into our table. We are giving a checkpoint location. So this is storing all information about our stream. And then we are writing to a table called IoT data 2025. The input rate is about 1,000,000 rows a second. The processing rate is like 990. If you run it long enough, you'll see it's going to be roughly 1,000,000 ports and loops. While this is running, we can quickly go check the output of this table. And again, we are producing 1,000,000 rows a second. So this is going to be really fast to get to 1,000,000,000. So let's see. So it looks like we have already done with like 518 million rows. So if we'll let it run for a couple of minutes, we'll get to our billion benchmark. Okay, coming back to our blog, let me tell you about this library, which is the core of this blog as well, which is called DLB Data Gen. It's an open source library by Databricks. What makes it distinct from other data generators is that it can generate data for your use case. So rather than generating truly random data set, what you can do is you can specify constraints. Why would you want to specify constraints such that it depicts your actual data? So that's why this is useful, which is saying generate data under these constraints. Example, when I generated the device ID column, I said add a prefix called dev underscore because my data is going to have a dev underscore. If when you're generating temperature, stick between a temperature range of -10 and 40. When you're generating humidity, the humidity rating should be between 0 and 100. If you have a device type, which is a categorical column, you can say pick between these values. Then another thing you can do is you can also say %null. So we are saying generate error codes between 0 to 999 and make sure 20% of them are empty, right? The beauty of the data generator is that it generates data close to your real data set. You'll have to specify what makes it real for your use case. So yeah, if you do this, you'll have your data and let's check where we reached. You'll here again see this numbers would keep bouncing. But in general, what you want to see is if you look at this graph, input and processing rate remain close to each other. We are already at 21 million. Okay, let's wrap up. This is going to be cheaper than your Starbucks coffee. I was also amazed that it's so cheap. On a 4-core setup, you are going to take approximately 17 minutes to generate a billion rows. Add extra 5 minutes as a buffer to actually get an instance, which is the time Databricks is waiting from AWS and Azure to give an instance to run that. So 17 and 5 together is 22 minutes, and 22 by 60 is 0.36 hours. Then I did the math and added the EC2 and Databricks cost together, and it's coming out to be 22 cents, which is amazing. And then I double checked my cost and I was like, why is it so cheap? And then I looked at the hardware utilization and it's always above 80%. We are utilizing the hardware very efficiently. So that's where this is coming out to be so cheap. Hopefully that all made sense. If you're new to my content, I write a lot about Sparks, Databricks, and Spark Streaming. I've been developing Spark Stream application for the last 4 years every day. If you want to keep in touch, you can join me on Discord, you can join me on WhatsApp, you can follow my website for the latest blog. Yeah, nice to meet you. See you, folks.